Cool. So welcome to the March 25th. Isn't it funny how the dates all blur together? CAD meetup? Let's call it that. We got a few people in the room here just so they know who's actually being recorded here. Nick's listening in. Craig's here. We got Tristan. We got Quentin. Team 17409, right, guys?
Yep.
Beauty. Plan for today is just to go through some basic CAD stuff. I'm throwing this in as a recording just so you guys know you are being recorded for any questions, any pieces of input you have, etc., etc. And we're going to learn some Fusion here. Do you guys want to do battery holder, or do you guys want to do a phone holder?
Let's do battery holder.
Do battery holder? Okay, cool. So key things we're going to go through here, just basically how to handle the Fusion file system, what Fusion is, how to make a file, etc., and probably the most important piece, sketching, projecting geometry, and then extruding out. What I've got here, and I'm just going to go down my actual list of files here and find our FTC CAD Challenges 2020 folder. Now I've got a few things in here. I'm just going to create a brand new folder for today's presentation. Meetup. Sweet. Now, I recommend that file organization, folder organization is a huge piece of this. We were just before the meetup started here looking at our actual 7277 FRC robot, and as you can see, there's a very significant folder organization here, including the climbing mechanism has its own actual folder. This is so that stuff can be, we basically find out where things are at any given time and build mechanisms into mechanisms. You basically build each sub-mechanism into a major mechanism, and then that stays organized in such a way that you can find things. You may find a few of the file names that were in that particular folder were not great. I yell at one of my CAD designers all the time because he doesn't like to name things properly, but I digress. If we go into our CAD meetup, you guys are probably looking at a page that looks kind of like this, new design. Don't worry about the blue background. I've messed with some of my display settings at the bottom here. If you want to go down here, you can actually change a whole bunch of different things. So my favorite visual style is shaded with visible edges only. This highlights some of the visible edges so you don't get some of that blurring that sometimes happens, but you can go all the way through wireframe, whatever you want. My environment's set to tranquility blue because we could all use some more tranquility in this day and age, but you're probably looking at something like gray sky or dark room. Or sorry, dark sky or gray room. There we go. Anyways, let's put this thing together. Now, with a battery holder, the main tool we're going to be using here is probably just going to be the extrude command. I'm just going to make a solid bottom bracket to hold the thing into place. Do you guys want to do Rev or do you want to do Tetrix?
Let's do Tetrix.
Let's do Tetrix. Okay, so first thing we're going to do here, because we're going to be basing this drawing on another object, something else that has to exist in this drawing, we're going to create our new file. I'm going to go ahead and save this file, and I'm going to give it a good name. Tetrix battery holder, and I'm just going to call it March 25th because I've probably got a couple other Tetrix battery holders somewhere in my file folder, just so I know what I'm looking for. Now, when I hit save on this, it's going to actually create the file over here in my file system, and it's going to give me a nice blank screen, which is awesome. Now, the other thing we need to do to make this battery holder work is we probably need a battery to measure based off of. So to do that, we just go upload, and if you're looking in the Discord, Quentin just actually dropped the Rev battery, but I've also got all of my CAD libraries in that, and those are things that you can definitely use. I'm just going to go in and actually go find my Tetrix battery. I should probably spell it properly. There we go. The 39057 Tetrix battery, and I'm going to press OK. This is or open. This is a step file. Fusion's really good at uploading things like step files into its cloud memory. Now, this is a cloud product. Basically, what that means is that all the information's floating around somewhere in the internet. Excuse me. And basically, that means that you can access this from anywhere. We take huge advantage of this when collaborating on things. I'm going to click upload, and what you're going to see is it's going to start uploading that battery up into my folder so that I can actually use it for some stuff. Managing these folders is half the battle. If you have one or two projects on the go, no big deal. Once you get up to 10 and 12, making sure these are in the right order, named properly, is hugely important. Actually, if any of you guys are taking design studies courses at school, it's actually also a significant number of your outcomes, believe it or not. As much as using the CAD format, CAD files themselves, it's a big piece. Now you notice that both these are version 1. As we save things, so every time I save something new, it's going to update the version number. So we're going to go back here, we're going to go to the Tetrix battery holder, and all we're going to do to start is we're going to drag a Tetrix battery into here to base our drawings off of. Now we could just start drawing if we wanted to. There's nothing wrong with that. Or we could actually bring this in so that we could actually draw things based off of it. So I'm just going to drop it in the middle of my screen. It gives me something to work with, gives me a starting point here. Now, key with CAD is this view cube. You're going to see me click this a lot as we work. It'll actually give you isometric views from any direction. It'll kind of be able to give you a front, side view and help you navigate. The home button is really good for setting up where you need to go to get yourself back into the right view so you can see things. You can also change things, like you can set a different view as home if you don't like this one. You can actually add views if you want to. I do recommend keeping a home that makes you able to see your entire project. Now, let's start by making a holder based off of this, and then what we're going to do is we're going to extrude some holes into it to actually bolt the thing down. So, first thing, everything we do in Fusion is based off of either a sketch, a body, or a component. Now, a sketch in this case is going to be the simple drawing in 2 dimensions that's going to create something. We run into a significant problem in CAD that we basically have a 2D input tool in your mouse and we're trying to draw 3D objects, so we kind of have to do this in 2 parts. And the first part here is actually going to be to actually draw that sketch. If we go up here to the top of our screen, and I'm just going to make my file system go away so we can see this a little better. Go up to your Create Sketch button. Now, when you create sketch, you're going to have to put it in a plane. You have 2 options. You can either create the sketch and put it on top of, or perhaps on the side of, any orientation of this battery holder. We have one other option, which is we can actually go to our origin here, and we can actually put our sketch into any of our planes. You can see highlighting the X, Y, X, Z, and Y, Z planes. In this case, I'm actually going to draw this on the bottom of the battery holder instead of using those different planes. Those planes are really useful sometimes for, excuse me, for actually putting things into different places in your field of view. A few other options, by the way, you can actually add some other planes through your construct menu. So like an offset plane if you want to start drawing something, let's say 5 millimeters away. Why don't we do this? Let's actually put an offset plane on this. So I'm going to click on the bottom, and you'll notice that it created a plane on the bottom of my battery holder. I'm going to offset it -5 millimeters, so 5 millimeters, I guess, going downwards. And you'll see what that does is it gives me a little bit of a gap, a little bit of separation to actually start drawing on. Cool. Now you notice that this battery actually showed up here on the in my browser. This browser is hugely important when doing anything CAD related, just because it's going to list all of your components, it's going to list all of the things that go into your actual CAD model. When we start dealing with joints and stuff, it'll also show you where things are connected. So let's create our sketch. We're going to create our sketch along this plane. You'll notice that it spun around so that I could actually see the bottom. I believe this is the bottom. No, it's the top of my battery. Okay. I'm going to spin this around so I can see the bottom of my battery. Go to the bottom. Now that looks a little dark. I realize we can't necessarily see that, so I'm just going to go, ooh, that's even worse. Let's go gray room. Can we all see that a little bit better?
That's better.
There we go, photo booth, much better. Now, the next piece here is we probably want to draw a battery holder. We could just simply take a sketch and draw something that closely approximated this. But where's the fun in CAD unless you can use some actual, let's say, precision with this? We have a bunch of tools here that are pretty self-explanatory. Lines, rectangles, arcs, polygons. I recommend you play with some of these. Most of them are pretty intuitive as to what they do, but this time we're going to use one that's not as intuitive. We're going to go into Project Include, and we're actually going to go to Project, which is actually going to allow us to project out all sorts of different things. Now, project is simply going to bring the lines into this current plane based off of another object that exists in this CAD. In this case, I want the battery holder, and I'm going to make a pretty educated guess here that if I project this bottom section, I probably will be able to offset it into something that can work. So I'm going to project that out here. And you'll notice that I now have these purple lines. These purple lines now exist in this plane, which means I can actually do stuff with them. If I go over and select them, I'm actually going to turn them into construction lines, and you'll notice that they went dashed there. I'm just going to highlight them again so you can see that. Everyone see those are dashed? Now, the difference between a construction line and a regular line is a regular line can be worked with. It can be extruded, it can have all sorts of things done to it. A construction line can't. And that's really important because the construction lines here, I don't ever want to really extrude them. I want to just use them for measuring stuff. So construction lines are really good as measurement lines. What we're going to do now is we're going to use that construction line with what's called an offset. Excuse me. Offset's one of your more powerful tools because if I go ahead and select an offset, here we go. Oh, it's already selected my curves. Fantastic. Since I'd already selected the thing, it's actually selected all of the things I need to offset. You can see that it's got 38 polylines selected right now. I could actually go in and unselect them if I wanted to. I don't right now. It's going to ask me how far do you want to offset. I'm just going to pick an arbitrary number here just to take a look at. That's 2 millimeters, that's 3 millimeters, that's 4 millimeters. Okay, I'm going to go about 4.5, just assuming that I'm going to 3D print this, and that I've probably got a tolerance of about a half millimeter or so, maybe 0.3, where this may or may not be accurate. So I'm just going to make sure that this whole bracket goes basically all the way out. And the way I'm going to do this is I'm actually going to draw some walls on the outside of this. So I'm actually going to add another 3 millimeters to the overall offset of this, just to make basically a solid base plate that we can start working with. If I want to offset inside, I can actually use this to go interior or exterior angles or offsets, and those are really good things to have. Press OK, and what you'll notice is that everything got highlighted a little bit green there. That's important because if I go back to my drawing, you'll notice that this, if I float over it, has now created an actual shape. And this is one that my students always fight with, is the difference between lines and shapes. Once you enclose a shape within lines, it will actually highlight like this. If you have left any of those lines basically unattached or unconnected, it will not create the shape. And without a shape, you cannot create a solid object. Now the nice thing here, and I'm just going to go ahead and finish my sketch up here in the top right, is that I'm now able to actually extrude this and actually create my base plate. So I'm going to click extrude. It actually guessed already that this is the only shape in this drawing, and so that it's what I actually want to extrude. Now what I'm going to do right now is I'm going to go up to my battery, and I'm actually going to click the little eyeball next to it. That's going to make the battery go away so that I can just look at this base plate. Because really all that battery was there for was so we had something to measure to, so we knew what the shape was. Now I can click and I can just pull, or I can pull either direction. In this case, I'm just going to go minus 5 millimeters because I know that based on what I drew, I actually, if I put the battery back, that's actually what I was basing it off of. So there's a nice base plate to get us started. Now, I'm going to make this battery go away, and we said we put a 3 millimeter wall on the thing, so I'm just going to put a little bit of a bracket on the outside of the thing. Now to do that, we're going to actually add another sketch. So we're going to go create sketch. This time, instead of going to a plane that we've created, we're actually going to sketch directly onto this object. You'll notice that when we sketch directly onto the object, I don't need to project any lines. I just need to actually draw because it's already assumed that everything in that plane is a part of what I'm doing. So same thing, I'm just going to go ahead and I'm going to create an offset here and select all of those lines, and I'm going to flip it inside by negative 3 millimeters. 3 millimeters is about all you're going to get off of a 3D printer for accuracy, for wall thickness. You may actually want to go a little bit more than this, depending on how durable you want this part to be. Alright, so now that I've got those lines, and I clearly, as I can highlight it, I can see that I have a shape on the outside of this. I'm just going to finish this sketch, and I'm going to go ahead and extrude this thing upwards. And again, I'm just going to go about, 20 millimeters, somewhere in there. Now, when I actually go ahead and extrude this, you'll notice that I'm actually adding things down here at the bottom to my timeline. This is kind of cool because I can actually drag my sketch back and I can actually see what each part of this sketch has looked like through its construction. Now for something like this, that's relatively simple, but if you're looking at something like the final robot CAD for an FRC robot, this is something that's actually going to be much, much more complex. And you're going to see pieces start to disappear as I drag this along and slow my computer down. You're going to see pieces disappear, possibly pieces change. It's kind of a cool piece about it. So now I definitely have a battery holder that if I look at it from the top, it's going to hold that battery in place. And as you can see, I've got a little bit of a gap here between the battery, and I'm just going to go to my top view. between my battery and my edge here. And if I want to, I can actually measure what the space is between them. That measured vertically. I'm going to go down to my... I'm going to find two lines that are in line with one another and try that again. Inspect, flat edge, there we go. So I got 1.5 millimeters between them. That, again, for a 3D printer, you assume a certain amount of kind of overflow or a certain tolerance. I usually like to go about 0.5 millimeter, so that gives you about 1 millimeter of play on the outsides. You might want to tighten that up depending on how comfortable you are with your 3D printer. Alrighty, let's make this so there was actually, back to home, actually a way to attach this to your robot. Do we want to do like a side mount, top mount? How do you guys want to put this thing in?
Let's do it side.
Side mount? Okay, cool. So to side mount this, we're going to have to go modify the extrusion a little bit. So what we're going to do is we're going to go back into our actual timeline on the bottom here. I'm going to hit escape. I'm going to go to my actual sketch that caused the base plate here, and I'm going to right click and go edit sketch, because to side mount this, I really don't want this wavy edge. That doesn't really help me at all. So we're going to actually create a straight edge so that we have something to work with, something to attach to. To do that, I'm going to grab my line tool, and I'm just going to go and grab a, I might have to click an arbitrary distance here. Okay, I'm just going to create a line here. And again, this line I really don't want to do anything with, so I'm going to make it a construction line. It's literally just there to create a 90-degree angle across my, my drawing. Okay, and in fact, I can probably just draw and delete that one if I want to. You'll notice that I actually have a constraint here. So this is a dimensional constraint, 7.5. If for some reason I decided I wanted to actually change this and maybe make this thing 8.5 millimeters, I could, and you'll notice that it'll actually modify the size of the overall bracket. And then if I go back, and I don't know if we were able to see that very well, so I'm just going to click undo, and it's 8.5. It actually will modify the bracket itself as we work with the constraint. Okay, so now that I'm here, I'm actually going to delete the extra lines that I don't need, and that is going to create some warnings, but that's okay. We'll deal with those warnings as we go. And you see what happened there when I drew that line? It just, with trimming out those extra lines, it now created a flat, straight edge. That'll give us something good to mount to. Just a sec. Emma, go upstairs for a couple minutes, okay? Sorry about that, guys. Okay, now we have a nice straight edge we can actually mount to something. Now, the thing we want to mount to is probably going to be a piece of Tetrix tubing. So what I'm going to do is I'm going to click Save, because you do have to save this occasionally. It's not Google Drive for you. And you'll notice that as soon as I save, it should give me a different version number here. There we go, version 2. Nice thing with this is it actually does save. Every time you hit save, it saves a new version number that you could revert back to. Let's say you're working on a team with 3 or 4 people, and we all have that one CAD person who just likes to do things for the sake of doing things, but it doesn't really help the cause. This is actually going to help you actually go back to a previous revision if you have to, see what somebody else has done. And believe it or not, with Fusion 360, you can actually get this on your phone, and you can actually check designs via your phone. I'm still working on using that one a little bit more frequently as a teacher. But let's go ahead and upload some Tetrix tubing here. So I'm going to go upload. I'm going to go find some kind of Tetrix tubing that I can actually base this off of. Let's grab a 160 channel step file. And let's upload. Alrighty. You guys making some of this in your screens as we go along?
I got stuck on the bottom piece.
Which part of it?
I can make the I forgot what you called it. It's offset pane.
Yep.
I remember that you could put it on the bottom.
So you are back here, right? Somewhere in this neighborhood?
Yep. Yes.
And so you were able to offset the projection, or did you not get to the projection?
I didn't get to the
Okay,
projection.
so if you go to create and you go down to project, you can actually just click the project button here and it will project something onto there.
Oh, nice.
And that's going to let you actually pull the geometry into the pane you're working on. Alright, does that help out? So let's do this. Let's finish that sketch. Let's actually make a mounting bar here. So I now have some Tetrix tubing that I can actually drag into my diagram here. It's going to take a second to load. Now the fun thing is when you drag something into Fusion, you can actually just drag it around and actually change its orientation. I'm going to turn this by 90 degrees. And I'm going to more or less line it up here so that I have something to work with. Now I'm probably going to design myself into a bit of a corner here. Unless I create a bit of a mounting plate, and that's okay. I think we will do just that. Alright, so we said side mount. Let's have some fun here. Let's make the battery go away. Let's move this in, and I'm going to try to make this plate about 5 millimeters thick. Again, depending on your 3D printer and how much you trust it, that number may change. Alright, so now what I'm going to do is I'm simply going to grab my bar here and I'm going to move it up in the world so that it's kind of aligned with the top edge of this battery holder. Again, I can type in specific values here if I want to. And I think I actually am. I'm going to go about 24 millimeters here. See how accurately I can line the thing up. And then I'm going to grab it again and just move it so that it is somewhat centered on this drawing, and then we are going to go here. Now, depending on your CAD design, where you put this is going to matter a little or a lot, as it were. So from here, a couple things we can do. I could definitely put a sketch and draw a really big rectangle along here, or I could spin my bar around. I could select, and sorry, I'm going to select the side of the battery holder here, and I'm actually going to make it so that I can actually draw my object here, and then I'm going to extrude it out. Just like we extruded upwards in the other one, this is going to allow us to actually extrude it. I'm just going to say capture the position. That just captures where everything is in space right now. Now, a couple things. Right now, I'm going to just go with a rectangle, very simply. Now you notice that I have access to this rectangle because it's the plane I'm drawing in, but I don't have access to any snaps or any way to, any geometry that's on the bar itself. We're going to fix that in a minute here. I'm just going to draw a very simple rectangle right up to the top of this bar. Yeah, let's go to the top of this bar right here. Okay. From here, I am going to go back and I'm going to go back to that project button, which, by the way, in robotics, at least when you're matching parts, this project button is by far my favorite part of anything in CAD. It makes life so much simpler. I'm going to actually click on this bar, and that is going to give me a sketch if I zoom around. You can all see the kind of purple sketch with all the holes in it. I'm going to spin this around, and then I'm just going to actually make my channel go away here, so everyone can see kind of how that has projected out, so that I can see all of the holes and where the Tetrix spacing is. It's way easier to do this than to try to redraw them for the most part. Now, from here, I'm actually going to finish my sketch right here. Now that I've got this drawing, you notice that I have a whole bunch of stuff that doesn't, it kind of makes sense. I think I'm going to go clean that up right now. I'm just going to go back to Edit Sketch. And I'm going to use my trim tool here, and I'm just going to trim away, I can't trim away my projections. That's okay. At the end of the day, that will matter very little because I'm going to match this up almost perfectly. But I'm going to add a couple things in here. I'm going to go up to my fillet tool. You'll notice with Modify, you actually have a few different commands here. Stretch scale is sometimes useful, breaking lines, extending lines, but trim is by far the most useful. I also like to fillet things. Fillet's going to give you nice rounded edges. So if I click here, I can give this a fillet of, I'm going to say about 3 millimeters just to round it off, make it look pretty. And then finish the sketch. Okay, now when I zoom out here, I know that the gap between those is 5 millimeters because that's where I've put the thing. The gap really doesn't matter here because we're working with a single part. But we're going to go ahead and extrude. And I'm going to click this part of the actual sketch. I'm also going to click on a couple of other little pieces here just so I make sure that I get all of it in. That also shows me that it wasn't quite centered. Apologies for that. And now, most importantly, I'm going to click on this bottom piece here. The little gap between them and the bottom piece. Everything in blue now will extrude out if I wanted to create a part, which is exactly what we're doing right here. And in this case, I'm going to make the part. If I go to my extrude menu, I have a few options here. So far I've selected some planes. I've selected some things I can work with. I'm going to start from this profile plane. You could offset this to make the part start away from this plane if you wanted to. Usually we don't do that because we're usually drawing in the plane we want to. We can also choose what direction. And it's kind of interesting here. You'll notice that if I go one-sided, I could also go symmetrical or two sides and actually tell it I want to go 5 millimeters in one direction and 3 millimeters in another direction. Now you notice that turned red. Red is a very useful thing in CAD in that everything we've done to this point has added material. If it turns red, you've actually switched your operation from join, new material, to cut, remove material. You also have another option. If you wanted to draw two shapes and only put material where they're going to intersect, everyone sees this little darkened piece at the bottom here. That's actually sometimes useful in CAD. I've seen it used a few times, but for the most part we stick to join and cut. You're also welcome to make new bodies or components from this. For the sake of where we're at with CAD, not very important. We'll probably use that a little bit later on. I'm going to join it, I'm going to make it one-sided, and I'm going to make it a distance of 3 millimeters. I can actually go -3 if I want to go in the opposite direction. That does work. I can also taper it if I wanted to for this. In this case, I'm going to go 3. You'll notice the -3 moved my cut in that direction. Actually, I'm looking at that, wondering if that might actually be the best way to do it. No, we're going to go with the original plan. We're going to put it 3 millimeters that way. It's going to beef up our battery holder a little bit and give it something to hang off of. It's going to create a bit of a cantilever, but you know, for the sake of this, it's a good start. Alrighty, so there's the basics of the extrude command. I'm going to show you one more thing here. I've got one more task we can work with, because if you want to make a few more fancy things, you do have some modify tools that are somewhat powerful here. Okay, one of those things is fillet and chamfer. If, let's say, we decided we wanted to actually cut off some of the edges here and actually like smooth this down, we also have that option to do this in 3D once we get to this part. So I'm just going to put I believe this is a chamfer. You'll notice that this is going to cut off a angled version of that particular piece. If we say wanted to remove some material or wanted to create an angled edge, we have that option. Fillet's going to create a rounded edge. We also have access to press pull, which is going to let us very easily just move some things around. If we, let's say, wanted to take and make this particular piece just a little bit thicker, we could actually use press pull to just pull this into, oh, it's going to try to delete the face. We should probably go back to our original extrusion for this one if we're going to do that particular maneuver. I'm going to make this a little bit less weighty. Not that it really matters with 3D printed parts, but I just want to show you how that cut move works, because the cut can be something pretty powerful. So I'm going to go put an actual sketch onto my battery holder, and then I'm going to go to my offset tool, and I'm very simply going to offset something onto the inside, and I'm going to go about 5 millimeters just to keep it nice and even, -5 in this case. I'm going to press OK. Now the reason for this sketch is very simple. This sketch is going to give us something to, I'm just going to zoom around here, it's going to give us something to cut out. If we ever have to save weight, which again, FTC doesn't happen nearly as often, I'm just going to go distance -5 millimeters, because I know that this piece is 5 millimeters thick. If possible, I recommend you guys pick some standardized measurements and kind of stick to them. It makes the CAD a whole heck of a lot easier. But if I happen to go way beyond this, you'll notice that I still get a cut that's way through it, and it will not matter at all unless I'm drawing something else beneath it. So, -5, here we come. Alright, now once we've done that, you'll see that it's actually going to cut the bottom of this battery holder out. The fun part being that the way battery holders work, if I wanted to make something stylish and make something that definitely showed up there, I could make this battery holder and it would still hold the battery pretty darn effectively. There we go, and there we go. Now we also check our clearance here to see if my bolts or my screws would go anywhere, would get in the way of the battery. I don't believe they would on this particular design, and that's going to let us actually have something that works pretty well. Any questions, guys?
That was a lot of fun, Mitch. Good job.
That was good.
And for the phone holder, same kind of thing. I mean, I'm just going to go to my phone holder demo here, and this is one where all I did, same thing. There's 3 parts here, and if you look at my actual, give me 1 second to go back to the actual folder here. Let's go CAD challenges. Okay, if you look at the phone holder, I've got my phone holder over here, and all I did was just create a Samsung. I was using S6 because it's what I had sitting on my desk. I just created a rectangular component here. I filleted off some edges, kind of like the phone was, and hit the thing with some calipers to figure out what size it was to make it really, really easy. And then that component just got dragged into my other design. So you can see this is the phone holder. That component, Samsung S6 phone, is in this design. Now you see the little link button here? That's actually kind of important. This means that this is linked to this Samsung phone elsewhere in the folder. So let's say I change the size of that phone, a lot of my dimensions will change to match it. So let's go back to the phone here, and I'm just going to go, I actually put some parameters on this one, so I'm just going to change the parameters quickly, and the phone was 7 millimeters by 70 by 145. I'm just going to change a couple of those. I'm just going to make it 100 millimeters. This might screw up my geometry in an epic way, but actually, let's go 45. Let's make the phone's profile a little smaller. Let's go 60 by 5 millimeters, okay? And you'll notice that when I change the parameters on this, I use some parametric design here. You'll notice that the phone got a lot narrower. It probably looks more like an S20 now. And when I click save on this, you'll notice that I now have a version 3 of the phone. But something else is going to happen here that's kind of cool. When I go back to my phone holder, you'll notice that I have a big exclamation mark here because it's saying that I don't have the latest parts from my actual folder. I changed something. These are linked, and that means that if I change the link somewhere else in the folder, it's going to change the geometry here. And now I'm terrified to see what this does, but I'm going to click Get All Latest, and we'll see what happens to my design. Okay? In this case, the phone shrunk, and it actually changed the part in here. Now, clearly, I didn't link my my sketch geometry to that phone well enough. I was trying to design this so that the phone holder would actually shrink to match the phone, but that definitely shows how these are linked and kind of helps with modeling parts with standardized sizes or sizes that have to match. I'm going to go and put my phone back. Version 4, let's go back to version 3, and let's restore my use of number. Here we go. Let's go back to number 3 here. Opening number 3, there we go, and I'm just going to make this the new current. Oh, it's open read only. Anyways, that gives you the basic idea of how this CAD stuff, this CAD piece works, and I hope it gets you something to get started with the challenges. So for the challenges, I want you guys to design some stuff. I want you to send me some, or I want you to upload some step files, some CAD files, or even some picture files if you just take a screen capture, and throw them in that folder that we put on Discord. It's also in the challenge folder if you go to the actual FTC. Sorry, if you go to the actual FTC site we laid out, there's actually a folder in there for us to upload stuff. Keep in mind if you're uploading stuff, and I think we're all good with this on the gracious professionalism side, I assume, can you guys see that right now? Assume.
Yep.
Yes, you can. If you just float down here, there's a couple things. Submission folder, if you upload your step or .f3d files, F3D is what you actually download Fusion files as, that would be awesome, and then people can look at what everyone else has done, and perhaps even you might find your part on somebody else's robot next season, because a lot of these things are nice, as the rules for FTC are a little bit different than FRC in that there's no real fabrication rules per se, but usually the rules are if you've released your actual files, so they could be reasonably used by the other people in your league, it's fine to develop them prior to the season. So usually you're not supposed to use designs that are developed in the off season unless you release them. So by releasing these out there, and I do recommend you engrave your team number in them somewhere. Engraving a team number is relatively simple. You actually should put them in the folder here, and that means they're available to any team that wants them in Alberta. Feel free to use them during the season if you want to, have them ready to go and good to function from there.
I was actually wondering, how do you put the team numbers onto a surface?
That hit me while I was talking about it, so let's do it. That's my Samsung. There's my battery holder. Cool. Let's do the thing. Okay, I'm just going to make these go away so I can't see them right now. We're going to try to put them on. We're going to be challenging here. We're going to try to put them on one of these curved surfaces. All right. So first thing, I'm going to create a sketch, and I'm going to create a sketch along a plane. Now, noticeably, I can't put them on the plane right now. So I'm just going to go to an let's go tangent plane. Why not? Just going to put a plane. You'll notice that a tangent plane is going to let me put a plane along a curved surface. I can change the angle if I wanted to. I don't. I want this to be kind of just along that edge there. I'm going to spin this around. I'm realizing as I'm working with this that I actually want to set this current view as home. View, there we go. Okay. I'm going to put this plane on here, and this plane is simply going to allow me to have something to sketch on. So let's go to sketch here. Now, just by playing with this, I can actually go up to my create menu, and I realize that I have a text box. So I'm going to click text, and you'll notice that when I click text, just a sec, I'm going to make a few things go away so we can see everything here. I'm just going to create a text box here, and you'll notice that I get my little menu here. Okay, the text I'm going to put on here is my team number. I'll put 7277 on this one. Okay, height is 10 millimeters. Angle is 0 degrees, and clearly it's drawn it upside down. So let's spin that around, and I'm going to bold it. I can also pick a text style, so if I want to put something that's a little bit unique, I can do that. I also have the ability to flip it. Sometimes that's important for things like laser cutting, where you have to flip graphics and stuff so they show up backwards, because once you laser them, they sometimes turn out backwards depending on the orientation of your part. Let's build this thing. Now, this is just this text is relatively easy in that it just shows up as a shape. I'm going to make my sketch palette go away, but I'm going to finish my sketch. I'm going to zoom back out. You'll notice that I now have that text kind of floating out in air in front of this. I'm now simply going to apply an extrude function to this, and I'm going to extrude it back. And I do actually have an option here to go to the object. So what that's going to let me do is if I go to object, it's going to allow me, where's my to object? There we go. To object, click on the object, there we go. Now you notice what's happened here. It's actually going to cut back towards that object, okay? And you'll notice that it also gives me the ability to select a distance. I'm going to engrave this 2 millimeters in. Oh, I clicked the wrong button. I apologize, guys. Let's go back to object. That object. Taper angle, offset, cut, objects to cut, we're set. Okay, this is going to allow me to go back a couple millimeters. I don't want to go all the way through the object, only part way. There we go. Let's go -3, just so I get it partially through. And that is going to allow me to, again, I apologize, guys. I thought I'd be able to get this cut all the way through. It might be because I've overlapped it slightly. Okay, once I go to the object, I believe I can put an offset of 2 here. Oh, -2. There we go. I'm just going to check my overall spacing on this. Is that going to go all the way through there, which I don't really want? -2. Apologies. This is one I'm a little less practiced with. There we go. That's what we were looking for. So to object, -2 in this case. You'll notice that it's going to curve the text. That's kind of what I was going for. If you have a curved surface and you have something show up not quite curved on it, it tends to look a little bit funky, but that's going to allow you to actually embed or engrave your team number onto your particular object. So, let's do this. On Friday, I would love it if we got everybody who's doing the CAD challenges together and just, we could almost say the same time, 10 o'clock on Friday, have everyone bring their designs, we'll share some screens, hang out on Google Meet, and have everyone show off kind of what they've created for battery holders, for phone holders, and even for alliance markers, which was another one of the challenges on there. I don't know if the alliance markers rules are going to change for next year. They were a little bit, I'm going to say, they were a little bit prototypey this year, so I imagine they may change a little bit, but if not, we can have some pre-designed and at least know how to design those, because 3D printed alliance markers are awesome. Though I do like laser cut ones. They do make me.
The laser cut ones are cool.
They bring me a great deal of joy. But anyways, regardless, it's good to know how to fabricate things one way or the other. One last thing before we go anywhere on this. I do have some, this is currently a body here. I'm just going to convert this over to a component. Components and bodies. Bodies are kind of like components in progress. Components are really good because you can drag them into other designs much more easily than a body. I also did this here because I actually just want to change the appearance of this. You could change the material if we're doing actual, let's say, weight analysis, structural analysis, things like that. For the sake of most FTC robots, it doesn't really matter. Right now this is considering itself steel, but realistically we probably want to turn this into some sort of plastic. So I'm just going to drag ABS white up here, and I'm just going to drag it onto the part to make it that particular color, and that'll let us show it in different colors so that we can actually differentiate our parts in larger CAD designs. Cool. If there's no other questions about that one, that's going to get you through those first kind of 3 CAD challenges in terms of phone holders, alliance markers, and battery holders, and we can meet up again sometime next week and maybe talk about the next challenge, which will be assembling parts once we upload some more step files.
Awesome.
Any
Thank
questions?
you, man.
Fantastic. Cheers. I'm going to end the recording on this, and we can hang out a little more if we need to from there and go from there.
Awesome.